Elon Musk has made shocking revelations about the James Webb Space Telescope that have left scientists and astronauts thinking. What has Elon revealed about JWST, and what impact does it have on space exploration? Join us today as we explore Elon Musk's revelations about the James Webb Space Telescope. What really is the James Webb Space Telescope? A question you might be asking yourself. In layman's language, the James Webb Space Telescope is a massive and complicated magnifying glass in space. In a more complicated definition, it is the most powerful and intricate observatory ever constructed by man. This space telescope was created by three space agencies: NASA National Aeronautics and Space Administration, ESA European Space Agency, and CSA Canadian Space Agency. It was named after NASA Administrator James E. Webb, who served from 1961 to 1968. The James Webb Space Telescope project began in 1996 with a $500 million budget. The telescope was planned to be ready for launch in 2007, but it suffered from several delays and cost overruns. In 2005, it had to be completely redesigned. The telescope was not finished until 2016 and was launched into orbit on December 25, 2021, aboard the Ariane 5 rocket after thorough testing. The total cost of the project was $10 billion. It took over 30 years to finish building this telescope. NASA collaborated with nearly 300 institutions, businesses, and organizations from the United States and 14 other nations. Northrop Grumman was the project's primary contractor. The launch of the telescope has attracted the attention of many people. Many have spoken out about the initiative, including Elon Musk. Humanity is only a few steps away from discovering the mysteries of the cosmos thanks to the space telescope. The James Webb Space Telescope is a significant success for NASA and the other organizations involved in its development. Elon Musk is aware of this, therefore he has explained why this space telescope is so important to mankind. The proficiency of the James Webb Space Telescope is what makes it so significant. According to the billionaire tech guru, the space telescope was designed to detect even the tiniest amounts of information carrying light. It can see images that are 100 times fainter than those seen by its predecessor, the Hubble Space Telescope. The stars we see presently are so far away that many are millions or billions of light years away. The telescope will follow these light sources back in time about 13 billion years ago. The telescope is constructed to reflect the genesis of stars. Its primary mirror, known as the optical telescope element, is used to collect light. This main mirror is made up of 18 hexagonal gold-coated beryllium segments. The gold plating on these segments is so thin that it is 1,000 times thinner than a human hair. The primary mirror has a diameter of 21 feet, giving the James Webb Space Telescope a light collecting area nearly 6 times that of the Hubble Space Telescope. Webb's telescope is designed to detect visible red light with a low frequency range and a long wavelength. It can observe things that are too far away for the older Hubble telescope to see. It has the ability to look straight through large clouds of dust where planetary systems and stars form. Webb's telescope is so sensitive that it can detect a bumblebee's heat signature from the moon's distance from Earth. Moreover, according to Musk, the James Webb Telescope is set to help astronomers not only look further out into space but also unlock and discover the first stars and galaxies in the universe, so humans can understand their secrets. The James Webb Telescope has a golden mirror that is incredibly helpful to astronomers as it helps them catch glimpses of the universe. The Webb Telescope is set to orbit the Sun 1 million miles away from Earth at what is known as the second Lagrange point L2. This is a neutral point in space about 1.5 million km from Earth's surface. In this spot, Webb's telescope will use its 5-layered kite-shaped shield to protect itself from being warmed by the Sun, Moon, and Earth. Significantly, the L2 orbit lets the telescope stay in line with the Earth as it moves around the Sun, thus allowing the satellite's large sun shield to protect the telescope from light and heat. The L2 is a solution to the three-body problem, found by 18th century mathematician Joseph Louis Lagrange. This implies that the L1 point is 1.5 million km towards the Sun. Many solar observatories, such as SOHO and ACE, are located there, while the L2 location hosts telescopes like Herschel and Planck. The marvelous modern scientific instruments revealed in the 21st century, beginning with the telescope, will travel millions of miles into space, equivalent to 5 times the distance to the Moon. Surprisingly, the telescope can form an umbrella-like shape, allowing it to deflect the Sun's powerful rays and function at a cryogenic temperature of about -370 deg, cold enough to see infrared wavelengths without obstruction. our understanding of the cosmos has grown immensely. The first image from the newly disclosed NASA Space Telescope bursts with galaxies and provides the most in-depth view of the universe ever taken. Bill Nelson declared in June that NASA would publish its first high-resolution color photographs from the James Webb Space Telescope on July 12th. According to the administrator, one of these photographs is the deepest image of our universe ever captured. At a recent conference, new cosmic photographs released included a stellar nursery where stars are created, galaxy interactions, and a unique glimpse of an exoplanet. After decades of anticipation, the world finally sees the first photographs captured by the James Webb Space Observatory, the most powerful space telescope ever built. Construction began in 2004, and after years of delays, the telescope and its giant gold mirror were launched on December 25, 2021. The photos were worth the wait and will forever alter our perception of the cosmos. Nelson stated that Webb will investigate solar system objects and the atmospheres of exoplanets circling other stars, providing insights into whether their atmospheres might be comparable to ours. According to NASA Deputy Administrator Pam Melroy, the Webb mission, initially expected to endure for 10 years, has enough extra fuel to continue running for 20 years. Bill Oakes, NASA's Webb project manager, mentioned that the Webb team was finishing preparations for the observatory and its sensors to gather scientific data. Engineers have noted that the observatory operates far better than anticipated. The team is also working on plans to prevent damage from micrometeoroids, like the one that affected a portion of Webb's mirror in May. True to its promise, the James Webb Space Telescope has provided astounding space images. Its cleanest infrared image of the distant universe showcases the galaxy cluster SMACS 0723, a breathtaking display. The first image, captured over 12.5 hours of deep-field observation, reveals the most distant image humanity has ever seen, taking us closer to the beginning of time and the edge of the universe. This image, followed by 4 additional cosmic beauty photos, highlights Webb's initial gazes. Webb's near-infrared camera revealed faint objects, such as the Carina Nebula, WASP 96 billion, the Southern Ring Nebula, and Stephan's Quintet. The spectrum of the massive gas planet WASP 96 billion is the most comprehensive exoplanet spectrum ever discovered. A century ago, astronomers believed in only one galaxy, but this image reveals thousands within a tiny speck of the sky. NASA Administrator Bill Nelson noted that photos like Webb's first deep field allow us to observe the cosmos as it appeared 4.6 billion years ago, light traveling through space for billions of years. After 3 decades of anticipation and 6 months in space, the James Webb Space Telescope's first full-color photographs provide an unparalleled view of our universe. Scientists believe we could be witnessing the first signs of alien civilization. However, much work remains to analyze the data. Regardless of definitive proof of life, the mere ability to observe another planet so closely is a leap forward, showcasing the extraordinary potential of new scientific tools and sparking curiosity about the cosmos mysteries. Methane, a compound often associated with biological processes, can also originate from non-biological activities, such as volcanic eruptions, rather than from living organisms. While oxygen is a promising indicator of life, detecting it directly with telescopes like the James Webb Space Telescope JWST proves challenging. However, ozone, a derivative of oxygen, offers an alternative. On Earth, ozone forms from atmospheric oxygen and is easier to identify than pure oxygen. If JWST detects ozone on Proxima b, it could serve as a significant clue, possibly the smoking gun for life. This notion raises further intrigue when considering the artificial nature of the strange lights observed on Proxima b. Some scientists speculate that these lights might result from advanced alien technology, perhaps from solar panels collecting energy on the planet's day side to power cities on its perpetually dark side. Although such ideas seem drawn from science fiction, recent discoveries make them feel more plausible. The potential to learn from another intelligent species is a dream for many visionaries like Elon Musk, and the possibility of life on Proxima b might redirect humanity's interstellar efforts toward this exoplanet rather than Mars. Signs of life there could imply a universe teeming with undiscovered life. Proxima b's unique characteristics make it particularly captivating. Unlike Earth, which experiences day-night cycles, Proxima b is tidally locked to its star, meaning one side remains in constant daylight while the other endures perpetual darkness. This creates a planet with extreme conditions, blazing heat on one side and frigid cold on the other. Yet, despite these extremes, there remains the tantalizing possibility that life has adapted to survive. JWST's infrared sensors have provided insights into the planet's heat distribution, revealing clustered lights resembling earthly cities. Such patterns raise questions: could these lights signify an advanced civilization harnessing solar energy, or are they the result of unknown natural phenomena? If intelligent life exists on Proxima b, it may have developed technologies to capture energy from its star and sustain its dark side, a feat echoing humanity's use of solar panels. Beyond observing lights, JWST is analyzing Proxima b's atmosphere for key life-sustaining elements like oxygen, water vapor, and methane. Early findings are promising, and the telescope's precision offers hope of uncovering the faintest signs of life. This exploration highlights the broader implications of finding extraterrestrial life, answering humanity's age-old question: are we alone in the universe?